Hello, this is a quick tutorial on how to program the flight controller that comes with all Hexy Hustle kits. So to start off, you'll want to get a USB-C cable and plug it into a computer and verify that all of the lights light up, or at least that you get some lights lighting up. There should be 4 individual red spots you can see through the print. And you can verify that the motor spins by plugging in a motor into any of the motor ports and verifying that it is spinning. And you can test all 6 of the motor ports to verify that they all work, which is handy to do before you go building a robot to make sure you don't have any faulty equipment. Same thing with a servo, is you can plug it into S1 through S4 to verify that the servo ports work. Make sure when you're plugging it in, you take the metal tab side of the servo and face that down away from the text when you plug it in, and you should have it start spinning. And once you verified that the brain works, we can then move on to programming it. So what you'll want to do is download the Arduino IDE from the Arduino website, and you'll want to download the Kitbot repo from my GitHub. And so you can download this as a zip, and then you'll want to install the Arduino IDE and open it up, and you should be able to, from inside of here, we're going to go to Files, Preferences, Additional Board Manager, and we're going to paste in the 2 boards that are listed down here in the README. And that will give you access to the Bluetooth libraries and the ESP32 libraries that make this thing run. And so then what we're going to do is, after we get those pasted in, we're going to go over to the board manager, and you're going to search for ESP32. And you're going to install ESP32 and ESP32 underscore BluePad32. You want to get both of these installed. I need an update clearly, but it should work. And then you can go to Library Manager, and you're going to search for ESP32 Servo, and you're going to want to get this ESP32 Servo by Kevin Harrington right here. And you're going to make sure you install both of those board packages and that servo library. And then from there, we can go ahead and open up the sketch that we downloaded. And so we can see I downloaded and extracted this, and you're going to go to code from inside of that downloaded folder, and there should be a code.ino. You can open that up, and that should open in a new window. This is all of the code that makes the Kitbot run. All right, once we have all of the libraries and packages installed, we are ready to actually upload our first program to the robot. So what you're going to want to do is hit this drop down here, and when you unplug and plug in the brain, you should see one of the COM ports appearing and disappearing. That is the COM port you want to choose for your brain. And then from here, we can go to Tools, and we could choose the board as ESP32 underscore BluePad32, and then we want this ESP32 dev module up top. You can also go to Tools and adjust this upload speed. If you're having issues uploading, try one of the lower speeds, like the 115,000 option. It'll be a little bit slower to upload, but it might be more reliable for you. And then we can go ahead and attempt to upload the program here. And I will cut back when that is finished. All right, now that the program has uploaded, we see a blue light underneath the pair button has come on. We can now grab a Bluetooth controller and put it in pairing mode, and it should automatically pair to the controller, and the blue light will turn off. And we can verify that we're successfully paired by plugging a servo motor into S1, which is where the flipper on the bot will go. And you should be able to press and hold L1 on your controller and get servo movement by doing that. And we've successfully uploaded our first program. If you would like to pair a different controller or repair your original controller, what you can do is take a small object and insert it into the pair button, and the blue light should come back on, and that means we are ready to pair with a new controller. Okay, so now if we want to modify our driver controls for our Kitbot, we can go into line 16 here, and we can start messing with the hang and intake controls. So by default, the hang is on L2, and then the retract is on Y. However, on a PlayStation controller, Y would be triangle. The button naming is Xbox style, where it's ABXY. And then the trigger naming is PlayStation style, where it's R1, R2, L1, L2. And so from there, we can program, hey, this L2 is going to move our hang forward, and then Y is going to move our hang backwards. And then by default, R1 and R2 are the intake, and then the flipper is on L1. It's a toggle, so when you press and hold L1, it'll move to the max position, and when you let go of it, it'll move to the minimum position. And then by default, it is in split arcade mode. That means your right stick will turn and your left stick will go forward. If you want to move it to single stick arcade, you can either put both things on the right stick or both things on the left stick by adding or removing the R in front of right after the axis. And then what you can do if you want to do tank is change both to the Y axis, which is forward and back. And then scroll down here where we assign the left drive, and we'll say the left will use the X and the right will use the Y, because we'll do right RY like that. And there we go. And so now this would be tank controls if you prefer those. And so if you are wanting to program your own robot that's not a kit, you're going to want to have a little bit of a deeper understanding of how this code works. So we'll give a quick tour top to bottom. If you bought a Kitbot, though, that you assembled from the kit, you can stop here, just modify the driver controls, and go ahead and upload. However, going through this, we're going to define our motors at the top here. So left drive, right drive is pretty self-explanatory. From there, if you have subsystems, you're going to create motors for them. And then if you're using servos, as opposed to a DC motor versus the servo motors, the 3 wires, you're going to define those with the keyword servo motor instead of just motor. And then it is helpful for your servos to define a max and a minimum value for them. The minimum value has to be at least 500, and the maximum value has to be a max of 2,500. If you set values smaller than that, you'll get less than the 180-degree range of rotation. If you set, in this case, I'm not spinning the full 2,500. We're not having to spin that far to actuate the flipper all the way. You can adjust these values after you've set up your robot if you want to tune the servo motion itself, but just note that 500 and 2,500 are a full 180 on the servo position. And then from there, you can go down to the setup function. And in the setup function, you have to leave all of these PSR init in place. I do recommend you set this to true if you are using an Xbox controller. If you're not, you can check if your controller supports BLE or not, and then enable it if you need to. But then our actual setup for the motors is here, where you'll initialize the ports, use M for DC motors, and use S for servos, and then you can start the servos in their starting position. And so in this case, I was supposed to start it at the minimum position, which is all the way back as far as the flipper paddle is concerned. And then if you add a 1, like a comma 1 after any of the other motors, it will reverse it, which can be handy since these cables do not allow you to flip polarity, so you will have to reverse them in code unless you want to resolder them. And then from there, you can go ahead and write your own custom drive controls as long as you have those set. The min and the max are just handy in this move absolute function, where you can say, hey, I want to move to this absolute value. You could also move a servo relative where it'll step it plus or minus wherever it's at now. However, that move function, the move relative, will not move outside of your min and max bounds if you set them when you initialize. And so there is an upper and a lower limit and an initial position. You can pass a lower and an upper limit into that function if you are using move relative. You want to say, hey, it's moving relative, stepping 10 at a time. I don't want it to exceed a certain value. Then you can pass that in when you're, if I would say, hey, I want this to physically not be able to go below the min and the max. And so that is a handy little trick for the servos. And then once you've defined all of your motors, you can then write driver controls in the same style.